cotton candy, and artificial organs. Let's take a view inside the lab of bioengineer Leon Bellin. Carnival rides and carousels fit perfectly with cotton candy. But Vanderbilt mechanical engineer Leon Bellin is using the sweet treat to create tiny blood vessels.
Much of that work is devoted to trying to mimic the capillary beds inside of your body.
The goal? To keep bioengineered tissue and organs alive. Here's how it works.
So Brad is actually making some cotton candy. It's actually a lot harder than you would think. It requires a good deal of practice and skill to make good cotton candy.
The researchers spin real cotton candy and a similar non-sugar material.
I mean, you could eat this. You probably wouldn't want to because it's been in the lab, but you could.
Then they pour gelatin over the cotton candy.
It's kind of like a Jell-O mold dessert. That's an example of a hydrogel.
You'd think everything would blend together, but Bellin figured out a way to dissolve the cotton candy on command.
When the Jell-O has set, then we change the pH and then the fibers dissolve,
leaving channels behind mimicking capillary blood vessels. Just like real capillaries, cotton candy channels are tiny.
About 1/10 the size of a human hair, roughly.
The channels have to mimic real blood vessels, so they need to be lined with special human cells.
Endothelial cells are the cells that line your blood vessels.
The challenge Bellin's team is working on?
How do we get the cells into the channels in a way that they don't clog?
Postdoctoral researcher Shannon Faley is growing the cells.
This is the cell media, so it's cell food, basically. It's with its sort of a balanced salt solution with some different nutrients that just keeps the cells happy and growing.
She sees the future potential of this cotton candy research.
Regenerative medicine is a huge field and it's really exciting, and this can really help in that aspect.
Bellin's dream is for all types of researchers to use these artificial blood vessels to keep tissue and organs alive.
We're really trying to attack a fundamental hurdle for the entire field. The sci-fi version would be that you would like to be able to basically build an organ from scratch.
And he wants the process of making capillaries to be affordable.
We use gelatin not for any particular reason except for that it's cheap. Cells love growing on gelatin. It's kind of a basic, easy material to work with.
Bellin's cotton candy machines are essentially adapted toys.
Instead of paying thousands or millions or tens of millions of dollars for the piece of equipment, you pay $40.
Bellin says this mentality turns research into reality.
Is this something that will ever be scalable? Is this something that will ever be economically viable? Because it's one thing to show that you can do it, it's another thing to show that you can do it in a way that makes sense.
Bellin has been surrounded by cotton candy for most of his career.
People always ask if I like cotton candy. I think it's actually kind of disgusting.
But if it changes the future of tissue engineering...
So I don't mind being associated with cotton candy forever. I think that's fine. Hopefully I'll do something else that's interesting and unique in the future as well. So, but I'll take cotton candy for now.